up the local, Taylor Valley, 3 on board, and I've got 1 plus 05 on the fuel.
Lima, Wilco, thank you.
What do you think, you just gonna need an hour, bud?
Yeah, that should do it.
Yes, sir. Close my local in the Taylor Valley. Landing in the Bonnie Regal. Give me 2 hours ground.
The tower. You want to leave copy 2 hours on the ground at Taylor Valley, over? Morning observer at the tower.
Yeah, roger, man. That works. Go ahead, Scotty.
Confirm you did not leave a fuel pump at Round Mountain.
That is correct. We did not leave a fuel pump at Round Mountain.
Roger that.
Landing site should be right around here somewhere.
Yeah, there's a circle somewhere.
Yeah. It's always hard to spot because it dries out and the markers are all faded. I think it's behind us actually. Yeah, that's the worm farm over there. There it is right in front of me. Some multicolored rainbow racks on the ground.
Camper, happy camper, this is South Pole, Anti, Weeper readable, how me, over?
Frequency.
What do we say?
Ask him what the temperature was last night. What temperature is now? What the temperature is.
Over.
The temperature here right now is about minus 31 Celsius, over.
We're at the Taylor Glacier Met Station. The main thing that we're trying to do is monitoring long-term climate, as opposed to seeing what the weather will be like the next couple days. climate is something, it's long-term weather, and it can be affected by lots of different things going on, so it can be very complex. So what looks like somewhat of a dead place is actually a very simple ecological system.
Just because you have the data doesn't mean you understand the system. It's important to come down and view the landscape, and in our case, view the glaciers and seeing how the glaciers are reacting to these changing environments. And that kind of feeds into our understanding in kind of non-quantitative way.
Being on the ground and seeing what a place is like and seeing what the weather is like there gives you an intangible sense of the location, and it improves your interpretation and your understanding of what your computer model is telling you or what the weather data that you're seeing is telling you. You're more fully immersed in what's happening, and it provides you with a lot of clues and a lot of bits to think about. If you're standing outside and you feel the gustiness of the wind, or you see the way the clouds are moving across the sky, they're intangible things that are providing you clues to what may be going on.
So can I ask you what everything is? So we got anemometer, we've got this acoustic
Depth gauge. And
depth gauge.
One on the end there is a temperature
That little cylinder?
cylinder, yeah.
Oh.
It's a radiation shield basically, so
Oh.
basically you want to prevent it from having sunlight directly on it.
Uh-huh.
Underneath the boom over here on this side,
Uh-huh.
there's like that little gold thing with a gray cylinder on it.
Oh, yeah.
That's a relative humidity.
Oh, okay.
So, and then inside here there's a pressure sensor. Measure the barometric pressure.
What's this other box? That's just a transformer?
Junction box. So
Oh.
these two
And take a picture of my hand.
cords here are the battery.
You want it back?
So they're buried
Right.
a couple feet, 3 or 4 feet down. And then on the side is the solar panel, and then this is the power cord going into the box.
As best I can tell, have down to the
Cool.
bottom of the hole.
It's more than that. Like, the history of biology, the history of life, where does that history come from? It comes from the rocks. Where are the dinosaurs? The dinosaurs are in the rocks, right? I mean, that's, all those people are geologists. They're specialized. So geology is an enormously broad science that brings together, like, physics, biology. Charles Darwin. What is you think Charles Darwin was a biologist?
No, he was a geologist?
Yes.
Get out.
Yeah.
Really?
There's no such thing as a biologist. Charles Darwin was a geologist. Now, a lot of the big name scientists, Leonardo da Vinci.
Geologist.
Yeah. There was no formal training as a geologist, but Leonardo da Vinci.
I didn't know he knew geology.
Yeah, he was obsessed with collecting fossils and shells from the mountains and trying to think in his head, how do marine fossils get up in the mountains? He actually had it figured out before the church. The church always said there was like this big flood, Noah's flood, the Great Deluge. And that explains all the fossils up in the mountains. Leonardo da Vinci knew that was bullshit. But the funny thing is, it's the foundation of all the sciences that deal with the Earth. It's even planetary science. All planetary people who study Mars, Venus, they're all geologists. But when you read about somebody who studies Mars, they don't say geologist. Well, but see, that's the point, though, is that at some point there are no boundaries, because a physicist who worries about the planet is that physicist is essentially working as a geologist. Mm-hmm. And geologists have to understand physics because, like heat flow, there's all these guys who worry about heat flow. The Earth has got a nuclear furnace in the middle of it. There's all these uranium and thorium breaking down. That's where all the heat in the Earth comes from. It drives all the volcanoes and everything.
Right.
If you're going to worry about heat flow, you got to be a physicist. And if you're going to worry about the magnetic field, you're a physicist. But they're still working on a geological problem. Mm. So it'd be hard to draw boundaries.
We feel that any environmental problem has a social and ethical and cultural context, basically, and that any solution is going to have to combine those approaches, because science isn't enough. I mean, in fact, science often is just one little bit of information that goes into a whole bunch of bits of information that go into making a decision.
What's the difference between art and science? And one of the conclusions we came to was that scientists report and artists express, and that they were interested in being able to express what they were understanding rather than report, or like a lecture where the students are coerced into comprehending what you're saying because they're going to have to take a test. The public is not, and so it has to be a more sophisticated, on one hand, a sophisticated approach to understand how to communicate, but also to simplify the science so that you can be comprehended. If you look at science papers and the graphics in them, if you study them and think about it, you can figure out what it means. But if you just have a glance, you probably won't.
I think fear is a big part of it, and just fear and sort of
fear of what?
fear of not knowing. I mean, not being an expert, right? So I mean, we've really been trained as scientists to think only about this very small thing, and to not extrapolate beyond our data. And I mean, that's just grilled into your head. And I think many scientists then feel that that they don't want to get into realms of discussion where they are uncomfortable. I think another thing is that I know this is true, that a lot of scientists feel that science is pure. I mean, there are the data, and the data are the truth, and that should guide everything, right? Well, we know the truth, so let's just act according to the truth, kind of. We know the climate's changing. Yep. What's the problem? Why are we hesitating at all? Well, that's not the only truth. I mean, there are many truths, and some of them have to do with poverty, and some of them have to do with, all sorts of things. And so I think that's been a real resistance, because scientists get frustrated because they say, well, we know the answer. I mean, why do we need to talk about interdisciplinarity? I mean, we know the answer. Yeah. It's like, well, you have to communicate that. You have to make it work economically. I mean, make it work in a social justice sort of way. I mean, so many pieces.
Yeah, I mean, I think that's becoming more clear now, just with this, kind of the resistance from governments and corporations to doing anything about climate change. I think it's probably making it more clear to the scientists that, there needs to be a way to bridge that gap somehow.
Yeah, and it's really shocking to most scientists that if you tell them that scientific information isn't enough, because a lot of scientists say, well, if we could just figure it out, if we just if we could figure out figure out what to do with these Tasmanian devils, or I don't know, I can't think of a good example. If we could just get the scientific data, then
if we were 100% certain of anthropogenic warming, then we would convince them.
Yeah, but even if we knew everything, it's still, you still have to work within a societal context, and that's one thing that's really hard for scientists to grasp, because it's almost like this fervor, we have the data, we have the answer, it's objective, it's real, it's true. And I mean, there is something to fall back on with science, of course. The data, are supposed to be objective, more objective.
Our responsibility is, even if a lot of people have difficulties to understand that, we have to deal with the fact that the climate is influenced and decided on now, and what will happen is something quite far in the future, considering a lot of management decisions, time frames as they're usually done. And humankind has to learn to deal with that, and has to do it. It will be a cultural achievement if we are successful, but it will be a disaster if we are not. If we don't manage to do that and to really succeed with this cultural achievement, even if it's a challenge we never had faced before, but that's a fact.
All right, got it. All right.
then maybe she can just schedule
Want
a
me to do a
time that's
countdown?
easy. Yeah. What if she came out to do it?
Okay. Already in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm a weather observer. We observe cloud heights, the visibility, whether or not it's snowing or if there's ice grains or ice crystals, as well as pressure and temperature and wind. I have a degree in meteorology, applied for this job to kind of get out of that and get away from computers and get back to the weather and get back outside. So there was a while when I looked up at the sky and saw equations rather than big puffy clouds. So I'm glad that that finally went away.
I think you have to love weather, obviously, to come here at all. And also you have to have a lot of attention to detail. For me, when I go outside to look, there's a moment of quiet where I just go and take everything in.
So we have an antenna on the roof, that little radio sound is transmitting this data, and then so it comes out on the radio. Then we just go out there to a modem. So we're just creating a sound that the computer can understand, and then this program just reads that, and then converts it all into our pressure, temperature as it's going up, and the pump temperature, and then the ozone is plotting right here.
Ah.
So that's our tropospheric ozone.
Section of the balloon here from the reel to here is going to fill, and then I'll let it go and it'll stand up. It'll be standing up above the drum.
So that's kind of the bottom section.
It's the top.
Oh, okay.
This is the top, and so it goes all the way down there, there's balloon all the way down to there. Then there's parachute, and it goes up and over the truck to the payload. So what will happen is this will get filled and it'll stand up, and it'll take about 45 minutes to an hour to fill completely. And then what they'll do is see that lever just by Reed's hand, that lever with the cord on it?
Yep.
They'll pull that, and that drum will go.
Ah.
And the whole thing will just rise up with a good turn around it, and then eventually it'll end up right up over the truck, and the truck will start to drive towards it, and then they'll just stop and back off and release the pins that hold the payload on the truck.
It's got to get exactly.
They want it absolutely perpendicularly under, and you can see with a little the ball up there that's attached to the truck, so you know that it's in a really good line. So they're going to go straight ahead. The worst thing is if you get an extreme wind shift up there, and it would somewhere off over to an extreme angle on the side. That's what they've been trying to wait for, is the wind strength up through to that 1,000 feet altitude to get stable.
Right, she's still putting off the pie balls.
They'll do that right till the very last minute, and they'll start doing them every 15 minutes now instead of every every half hour, which they've been doing.
And if the balloon it gets filled up, but it doesn't seem like a good idea, it's just pack it in and.
Well, once they put gas in the balloon, that's it. The balloon is
going.
toast. Well, not necessarily it's going. I mean, if the wind suddenly picked up and they had to let the gas, they could let the gas out by the valves.
Yeah.
But that's the end of that balloon.
Yeah, but they want to save the payload.
They want to save the payload at all costs, yeah.
A model is only a caricature of, or a cartoon of the reality, and it will never match reality, and it actually wouldn't make sense to match reality. Then we don't need a model, then we can as well study it in reality, and we're even better off. And sometimes that's actually a pitfall. People build too complex models and then have to struggle with the same difficulties they would in reality, and the model is certainly less worse than the reality, so they would better do field work.
Antarctica is like the air conditioner at the bottom of the planet. You know, it's a big, huge chunk of ice, and it takes a lot to melt that ice, so it's going to be around for a long time. It's going to, as it disintegrates over time, though, that melting water raises sea level, and that's the one that most people know about, is sea level is raised by melting Antarctic ice.
How dynamic is the ice boundary of Antarctica? So how fast is the boundary changing? For example, ice shelves on the margin of Antarctica, these are huge areas, and we can observe major calving events which change the boundary of Antarctica. For example, at the last ice shelf during the last 10 years or 12 years or so, 15,000 square kilometers of ice was lost. And that event happened in a very short period of time. So normally, cryosphere or glaciers, especially glaciers in Antarctica, are believed to be very stable. So what we can observe in a very short period of time is in a way unexpected, because we thought, okay, it's just changing within hundreds of years, but now we see, okay, it can change within weeks.
But you have to see, we need models when we wanted to see what future impacts could do to our environment, and for those reasons I believe we need the models despite all these deficiencies. However, it's not that bad. Even a cartoon usually has some truth to it. And even if it's distorting certain aspects or exaggerating certain ones and neglecting others, it is still only a good cartoon, you would say, if it matches some reality, if it resonates a string in you when you look at it. And I think that's exactly the same we have to do in science. We have to build models which have a relationship to reality which captures the crucial properties you're interested in a given context. This means if you use a model in climate change, it has to have different properties as if you use a model, let's say, to study what nutrients do and how you could fertilize forests, or how you could get more out of plantations and so on. And that's actually, in fact, also the case. We have different models depending on what the purpose is for which we use.
Everyone would admit that it's hard to make a model where you can say, yes, 100% sure this is the way it's going to happen. But the way that it works is they run a whole bunch of different models, and they run them with all kinds of different parameters. And they don't draw a line of what the temperature is going to be like. They draw an envelope, and they say this is what the range of the change is going to be. And then they start looking at some of the assumptions, and they narrow that range down to what is likely to be the envelope of change. And if you do that with in enough different ways, you become really confident that, yes, it's going to fall within that envelope, because you can't even make the models go outside of that envelope.
If you want to ridicule someone with a cartoon, you draw it differently than if you want to make a joke, or if you want to emphasize the pleasantness of a person or whatever on which you do the cartoon. So you can imagine that in a similar way. And this means it's not just an art, or it's not just a arbitrary. We also test our models in particular to perform well in a changing climate, and that's why we use these models not only in the present to correctly reproduce or mimic what we find today. We also, where we don't have that much climate change yet, we use those models particularly also during past climate changes, where we had big climate changes of a similar magnitude as we expect for the course of this century. And that is, for instance, at the end of the last ice age. We have data from those times. We've done such studies. Exactly the same thing we're trying to do with the model to reproduce and simulate, how we call it, the change in the vegetation at that time. And if we match what we found in the pollen records well, then we say we have done a useful test for our model and we're ready to use it to make projections into the future.
We get a lot closer to the truth with every step. So I think that's what we're doing right now with climate science, is there's more information coming up all the time. And some of the things that we don't know about, to me, are the scariest.
Oh, what a question. Okay, I have to give you several answers, I'm sorry. One answer is that I think as scientists we have an obligation to inform the public, who is generally also funding us. Mm-hmm. And I'm glad it's funding us, because it gives us independence, and we are neutral in our statements, and we can remain that. And I think that the downside or the other side of the coin means we have to provide information to the public if they are in need. And the second thing is, I think there is a need for that kind of information, because I have to admit, as a scientist, I'm also a human being, I'm also a citizen of this country I'm working in, and having done, I also have kids, by the way, and by having done this research, just a little anecdote, when I started for this new report, I was quite confident I wouldn't get sort of shattered in my emotions much by what I would be doing. But actually, by widening my focus on what I'm studying and reviewing, and you have to do that when you do a job like I have been doing. This is mind-boggling. We dealt with all ecosystems, from the sea ice biome to tropical coral reefs and tundra forests, grasslands, savanna, deserts, mountain ecosystems. And usually I'm just dealing with mountain ecosystems and forests, but not with deserts, not with savanna, not with marine ecosystems. And so I was forced to assess a kind of literature which I usually leave aside. Because we have to specialize, we have to compete within the scientific community. Now, by having done that and broadened my perception, I have to admit, I was shocked. I was shocked by finding how sensitive many ecosystems are and how much they could be impacted by climate change in the future. And so I felt actually myself, again, as a citizen, as an individual, as a human being, an obligation to tell other people who are willing to listen and who are interested in this topic, and I believe everybody should be, by the way, it's their life. And for those reasons, I think it is important to really assess the risks we are facing and to think about decisions we have to make now. Now we have to make them. We don't have much time. In some respects, it's even what we call 5 minutes after noon and or midnight, and in another respect, in terms of avoiding a really strong climate change or a really large climate change. It's not too late, but it's getting very, very small, this time window within which we can still act.
That one paper about that one area on the Earth was taken as evidence that all of the globe is not warming, so it was misused. And I think because of that, scientists are a little bit scared of, there's a bit of spin going on from the other side as well, just to try and keep it from getting out of control. Because you can go out and you can find areas in the Earth that are right now, like Antarctica, not warming, they're cooling, but that's you're not going to expect the whole planet to be red.
Sure.
But it's the averages. So I can get shot if I if I said this. I don't want to go too far with this because but I think that it's important that both sides focus on the facts and just state what the data is, state what the interpretations are, and stop the spinning. And when you do that, the story is that the globe is warming and that we are in trouble, right? I don't see how anyone can argue against that.
We have a climate crisis, and that calls for everybody, wherever they are, whatever they do, might they be artists, journalists, whatever, scientists, we have to do our part in this.
And I think the public, as well as scientists, need to understand better that the media is not there to necessarily bring you objective information. They're there to sell cars and whatever.
10 years ago, scientists were reticent to come out and speak about their science, and I think more and more the message is getting through that there's a war going on, essentially, and especially in the last, about the last 8 years or so, there has been this war on science, and we've become less trusted. And so we've actually had to take to the street.
Just science, it's a more cultural thing.
Mm-hmm.
I think
Well,
it is, because my understanding of the role of a scientist is not someone who tells you what the truth is. Because as a scientist, I'm more humble than that. I think, yes, we have a role. We have a critical role, I agree, but we don't have a too big role, in the sense that it has to do with risks, because we have a lot of pros and cons in this issue, and without debate on that, which is value-based, there's no way we can decide. And also, as scientists, we are funded for doing certain research, and we funded less for doing others, and that is influencing the scientific outcomes, not in the sense that the scientific outcomes in whatever study you're looking at, if it's well done, it gives you the same result, and there is some objectivity to it, but the selection of topics is something which is done in a dialogue with the general public, with society in general. There is a contract between scientists and the society.
The most important thing is to keep in mind that we have very good observational tools, and that we can observe a high complexity and a high variability, and to understand that many observations they might look controversial, but because of the complexity of the system, they actually, if you look closer to it, they actually fit together. So I would say it's important to keep in mind for the public to filter out that noise in that press releases and in that reports in newspapers. That's very important, and to keep the big picture in mind. Most people's understanding of time is so pathetically thin and insignificant. Human life scales, like I think some things just drive you crazy. Like there'll be people talking about like a forest fire, for example. And they'll say, we shouldn't let these forest fires burn because, it takes, 100 years for that, it'll never come back. Mm-hmm. Which is just pathetically stupid. In the life of a forest fire is a second.
Yeah.
Compared to your life. The point is that you may see that as devastation, and your grandchildren may see that as devastation, and their grandchildren may see that as devastation. But the trees would come back on their own time scale, not your time scale. So human beings in general have this horrible understanding of how old the earth is, how slowly some processes work, which goes back to like why you shouldn't fuck it up. We could completely screw the earth up and it would come back. The problem is that it might not come back for 1 million years. Now to the earth, 1 million years, who cares?
Oh.
It's nothing. But in human history, you fucked yourself.
There's definitely going to be shifts. And in those shifts, some places are going to be better places to live, but places are going to be worse to live, and it's going to be a reorganization of human civilization. I mean, it's a big impact, and I think that part is really difficult to predict. And it's not, that's not a scientific prediction. That's more of a sociological prediction, is how that would all shift around and how that would impact economies and so on.
But let me come back to, if I may, to the smoking gun. Okay. It's not a smoking gun; it's a smoking machine gun.
Oh.
So one bullet was already fired, and there are many more in the magazine which are ready to be fired as well. And now, unless we do something, we cannot avoid these bullets to come as well. And that's the issue. And that's my second point. A lot of people consider climate change as being sort of a monolithic thing to deal with. It's not the case. That's, for me, the second most important thing people should learn about and think about, and that is, we have a choice. The choice means we can still avoid a very large climate change, and a very large climate change is one where we risk to trigger runoff processes which will feed back on the climate and speed up the climate change in a way which is much more scary than what the more moderate projections indicate. And for those reasons, I believe it is very important.
I don't get panicked about climate change because it does happen all the time. I get panicked about, like I said, the things we don't know. If we push this system so far in one direction, can we ever get it back? And what are the consequences? I think that the models can only tell us so much, and they don't tell us about these switches that can throw us off.
The science is the asking of questions. That's the science. That's where the brilliance and the intelligence and all that comes in. Science is the asking of important questions.
The more we learn, the more questions we have, so that things spread out and the questions, more people are answering the questions, and then we get more precise, and we criticize each other's work so that we can hone it into something that is totally objective, or as close to totally objective as we can get. But the artist is, his tool is the metaphor, and if he can relate this information, whatever he or she's trying to convey, to the biggest audience, then that's what they're after.
We're all part of the problem, we're all part of the solution as well.
I don't know the answer to those. I think about those questions all the time, but I don't know. I honestly don't know the answer. And I don't have I don't know. I have a scientific mind, and a scientific mind needs data, and I don't have the data.